Here you are asked to find the impedances of the elements of this circuit when ammeter reading and voltmeter reading are known to us. This ammeter gives the effective value of the current drawn by this source, and this voltmeter is taken here to measure voltage drop across 10 plus jx2 impedance. And you have to find the circuit elements, means you have to find jx2 value and then you have to find the value of x1. So here voltage drop across this is known to us. Current through this element is 6 amperes and this voltage source is written as 141.4 by root 2, which is 100 at an angle 0 is the value of this source voltage. Now from this you can directly find impedance of this is square root of 10 square plus x2 square, which is 16.67 ohms. And from this impedance that is obtained here is directly V by I, which is 100 by 6, which is equal to 16.67 ohms is the total impedance of this. From this resistance is 10 ohms. So reactance of this particular element is 13.33 ohms. Okay, next we need to find the values of R1 and JX1. Which could be computed from the effective power dissipation of the circuit. It is given that the power dissipation is at lagging power factor. So the value of the power factor of the circuit can be obtained as the value of VI cos phi is 450 watts. V is known 100 volts, I is 6 amperes magnitude, cos theta is unknown, and it is given that it is lagging but value is not given. 450 watts is the value of P of this entire circuit. So P is VI cos phi or cos theta. From this we can find the power factor cos phi as 0.75. 450 by 100 into 60. P by VI will give us cos theta. From this, theta is cos inverse 0.75, which is 41.4 degrees. Now, value of the current can be written in terms of the phasor form, and voltage across 10 plus J 13.3 can be written as 100 at an angle of 7 degrees. Now, voltage across this parallel branch can be obtained from V bar is equal to Vs bar is equal to voltage across this plus voltage across this. Remember, these are the vectorial additions. From this voltage drop across this branch can be obtained. Current is known to us. From this, impedance of this entire branch can be known to us, can be obtained. And from the current division principle, we can divide the current in opposite ratio of the impedances, and from that we can find the value of the impedance. Take your pen and paper and you can solve. Finally, you can verify the answers. It is also another small problem to determine value of voltage across the source. Here source voltage is not known, and power factor of the circuit, if the circuit delivers 100 watts to the if the source delivers 100 watts power to the entire circuit. Find also the reactive power drawn from the source. So Z equivalent can very easily be obtained. 2 plus J2 in parallel with minus J5, and the combination is in series with 5 ohms. Now power delivered to the source is given as 100 ohms, which is magnitude of I square into resistance of this Z equivalent. From this, magnitude of the current can be obtained. Of course, power factor is P by S. It is also written as R by Z when R is known and Z is known. When R is known and Z is known to us, cos theta is R by Z, which is 8.85 by 8.88, or tan inverse of imaginary part by real part will give us power factor angle 4.97, and cosine of 4.97 will also be 0.99 is as the power factor of the circuit. So Vi cos theta is known. From that, magnitude of V can be obtained. When V is known, I is known, phi is known. Vi sin phi is the reactive power. It should be Q here. Reactive power of the circuit is 8.88 watts. Of course, when V and I phasors are known, Vi conjugate will give us the value of apparent power, which is the combination of real power and reactive power. We can verify that reactive power here is 100.2 and here it is 100. Next, with dependent sources, you are asked to solve this problem. Determine average power delivered by 500 at an angle 0 source, and also determine average power delivered by the dependent source. So here, when Vm is considered, Vm is considered here. So to find the final powers, either Vrms and Irms are written, or Vm Im by 2 is given, because it is a sinusoidal value. So these are sinusoidal sources. Vm by root 2 is RMS value of voltage, and Im by root 2 is the RMS value of the current. And here a simple KVL equation can be written. From this we can find the value of V4, and also the value of can be solved for the value of the current. Now power delivered by this is either Vrms into Irms or Vm into Im by root 2. So here you write, when you write here by root 2, you can verify the answer here. And power delivered by the dependent voltage source can also be written. And for the circuit, another problem is for the circuit shown in figure, find average power delivered by the voltage source. So average power delivered by this voltage source is to be obtained. We can take a simple KCL equation here by considering a single node V, and from this we can find the current here, which is equal to this V voltage source Vs minus V by 2. Remember, Vs and V bar are the phasor values, and power delivered by the source can be obtained. Like this, you can practice so many problems to have an idea of the solution of the single phase AC circuits. Thank you.